So the great thing about indices is there's a set of index rules that can make the maths that you have to work out a heck of a lot faster. The only thing is they're only able to be applied to multiplying or dividing. So only use them if you're multiplying and dividing only. I'm going to show you what people do wrong in all of their GCSE exams, especially when using Pythagoras. And hopefully once I've shown it to you, you'll never do it yourself in your final exam. So what you often see is this. People look at it and go, oh, well, I've just got 4 squared plus 2 squared, so that must be 6 squared. But they never actually check it. So let's have a look. 4 squared is 16, plus 2 squared, which is 4, plus 6 times 6, which is 36. Well, does 20 equal 36? No, it doesn't. So to show a mathematician that we understand this, we put a line through the equals as if we're crossing it through and saying it's wrong. And this means never equal to. And you must know that sign because you might have to use it in your exam. So the only way that you can ever use shortcut rules is if you're multiplying. Never ever think that if you're adding to or subtracting two different rules that you can shortcut them. Now what I'm going to do is actually show you what shortcuts you can use. So here's my first shortcut rule. If I have 2 times 2 and I multiply that by 2 to the power of 6, so 2 times itself 6 times, 1, 2, 3, 4, 5, 6. In total we actually have 2 to the power of 8. So the shortcut trick is this. If you're multiplying two identical bases together, this will only work if you have the same number at the bottom of both powers. You can just add them. Now how we'd write that in algebra is we'd say a to the b times a to the c. Notice that I've got the same base in both, equals a to the b plus c. It just means that the base stays the same, you do nothing to it. We're not going to do 2 times 2 because that would give us 4, and our powers aren't written on top of a 4, they're written on top of a 2, so we keep it as it is. And we add the two powers together, and this is called the addition multiplication rule. Okay, so this is the next rule. We have 2 to the 6, which is 2 times 2 times 2 times 2 times 2, divided by 2 to the 4, which is 2 times 2 times 2 times 2. So 2 divided by 2, if we simplify 2 divided by 2, that's the same as 1 over 1. So these two we can simplify to 1 over 1. These two we can simplify to 1 over 1. These two we can simplify to 1 over 1. And these two we can simplify to 1 over 1. And we're just left with 2 times 2 on the top, because 1 times 1 times 1 times 1 times 2 times 2 equals 4, or 2 squared. And on the bottom I'm just left with 1. Anything, so here look, we have 2 squared over 1. Well, as with any whole number, any number that's written over 1, we can just rewrite, rather than writing it as a fraction, because 13 divided by 1 is 13, we can just write it as it is. So we would just shortcut this to 2 over 2. Notice that because we're cancelling through, essentially what we're doing is we're removing whatever is the same on the top and the bottom. Now there were 4 on the bottom, but 6 on the top, so the difference between them is 2, so we have 2 left over. So the rule is that you would take 4 away from 6, so you minus them. So 2 to the 6 over 2 to the 4 would equal 2 to the 6 minus 4, which would give us 2 to the 2, which we've already worked out. how you'd write this in algebra is you'd write a to the b, a to the c, and that would give you a to the b minus c. So when you divide with powers, you can just take them away from each other. So you take the bottom away from the top. So it should be an equal sign there. So the two rules we've got so far is if you're multiplying two items with the same base, and this works for more items, a minimum of 2, you add them. Remember that the base doesn't change because you're just stating what power you've already sat it on. Sorry, what base you've already sat your power on. And then when you're dividing, you just take them away from each other. So top minus the bottom power.